In the previous video, we tried to understand and explore logarithmic plots. In this video, we're going to discuss how to create a stem plot. We'll use matplotlib to plot stem plots using the stem function and see it's working. A two-dimensional stem plot displays data as lines extending from a baseline along the x-axis. A circle, the default, or the other marker's y-position represents the data value that terminates each stem. In this video, we'll be discussing about how to create stem plots. Make a note, do not confuse stem plots with stem and leaf plots, which are a method of representing data by separating the last important digit of values as leaves and the higher order values as stems. For this kind of plot, we need to use a sequence of discrete data, where ordinary inline plots wouldn't make sense anyway. Plot discrete sequences as stems, where data values are represented as markers at the end of each stem. Stems extend from baseline, which is usually at y0, to the data point value. We'll use matplotlib to plot stem plots using the stem function. This function can use just a series of y values, when x values are generated as a simple sequence from 0 to len of y minus 1. If we provide the stem function with both x and y sequences, they'll be used for both axes. What we want to configure with stemplot is several formatters. Line FMT. This is the line formatter for stemline. Marker FMT. The stems at the end of the line is formatted using this argument. Base FMT. This formats the look of the baseline. Label. This defines label for legend for stemplot. Hold. This holds the current graphs on current axis. Bottom. This sets up the location of baseline position on y-axis. Default value is 0. The hold argument is used as a usual feature for plots. If it is on, i.e. true, all these plotting is added to the current axis. Otherwise, every plot will create a new figure and axis. To create a stem plot, perform the following steps. Generate random noise data. Configure stem options. Plot the stem. So here's the code to do it. First, we need some data. For this video, the generated sampled pseudo signal will suffice. In real world, any discrete sequential data can be properly visualized using stemplot. We generate this signal using numpy's numpy.linspace, numpy.cos and numpy.sin functions. We then set up the label for the stem plot and position of the baseline, which defaults to 0. Now, if we want to draw multiple stem plots, we'll set the hold to true, and the following plotting calls will be rendered over the same set of axes. Here, call to a matplotlib.stem returns 3 objects. First is the marker line, instance of line 2D. This holds the reference to a line representing the stems themselves, rendering only the markers and not the line connecting the markers. This line can be made visible by editing the property of the line 2D instance, which we will explain soon. The last one is also a line 2D instance, baseline, holding a reference to a horizontal line that represents the source of all stem lines. The second object returned, stemlines collection, Python list at the moment, of line 2D instances representing stemlines, of course. We use these objects returned to manipulate the visual appeal of the stemline plot using the setP function to apply properties to all lines, line 2D instances, in those objects or collections of objects. So, we're now ready to run this code and check the output. As you run this code, it produces these plots, which you can see on your screen. Awesome! In this video, we've learned to create a stem plot. In the next video, we'll learn about drawing streamlines of vector flow.